We begin this session by first learning how to run WinServe. WinServe is, after you install WinServe and WinServe 2, you will see the icons that are on the screen on the desktop, and the icon for running WinServe survey is the icon that's being highlighted here. You can also run it by going ahead and selecting the programs using the Start button and then going down and finding the WinServe directory, and under there you can see that there's a program called Doctor, hasp key installer, and uninstall program in WinServe itself. The Doctor is a program which we use to revitalize WinServe if it's hanging up trying to open up a corrupted file. The hasp key installer is a program that you'll use shortly to install that you use when after installing, and you install that driver for the hasp key, the security key. And the uninstall is, unlike standard Windows installers of 32-bit systems, it's the program that you would run to uninstall WinServe survey. And getting back to the screen, the desktop here, we'll go ahead and we'll run WinServe. And WinServe opens up, and you can see that there's a version number that's being displayed here, and that's something that you also see at the top here next to the copyright information. The version 2008.02.23 refers to the version and the date of the compile. In this case, obviously, on February 23rd was the last compile. Maintenance updates are made for various reasons, to respond to the needs of customers and sometimes to fix bugs that have never been reported before. In general, this is an extremely stable program. It's been in production for 13 years, and it is aging, but it is a program that will probably be used for some years to come, as long as the operating systems will run it. It will not run under a 64-bit operating system. There may be a way of running an alternative operating system to run it inside of a 64-bit, but to date I don't know of any. When you come up with the, okay, let me stop there. The next step in the process of running WinServe is to create a project file, and the project files are special text files that are created by WinServe, and they have a SVY extension on them. Now, the DOS names themselves are limited in the length of the name that they can have. They're limited according to the old DOS 8.3 convention, which means that the file name itself can only be 8 characters or less in length, and the extension itself has got to be 3 characters. So we're going to go ahead and create a new file here by doing it the way it's normally done in Windows, by going File and then New. And we're going to look for a place to store our file that we want to create. So I'm in the H directory here, and I want to go ahead and store my data in the WinServe directory. So I select the WinServe directory, and I have some files here that are already in there, but I'm going to type in one called class, and you can see that it has been registered right here. Now then, once I do that, it clears out all the data all around the screen and all throughout the program. All of the settings for the reports and plots and everything that were in the previous file that we had there have been erased, and we start off with a blank slate. The way WinServe organizes its curve data is by using the concept of curves, and each curve is a survey file, and that survey file can represent a survey or a proposal or an offset well, and you can even use those to represent lease lines and other things. There's ways of doing that as well. The first 21 places, there's 30 curves that you can store, and 0 through 20 are the ones in which you can store data from offset wells. and the well that you're drilling on and your proposals and all those. Curves 21 through 29 are reserved for projections, internal projections, and 21, 28, and 29 are all very specifically reserved for very specific purposes, whereas 20 through 27 are used by various different types of processes that go on throughout the program. The section that we have right here is something which where we show in a tabular form what the last survey is. And that survey can either be the survey which is at the sensor point where the MWD sensor is, or at the bottom hole location. And the distance from the sensor to the bottom hole location, the bit to sensor distance, is stored here. We also have a very quick look at a least distance on this section of the screen, and you can turn that on and off, and it looks at only one curve at a time, so you're not looking at a whole bunch of curves. If you want to look at a bunch of curves, you can use this normal button, which we will go over later on. This area on the screen right here is the grid area, spreadsheet-like area, where you display the curve data that you have currently selected. So if I had curve 0 selected, I would see that. I have curve 1 selected, I would see that data there. And the big buttons down on the bottom of the screen are there for doing pretty much what they say they do. Targets for target editing, info for putting in basic header information. The well planning button is a button which is activated on the well planning version of this program and inactivated on the field version of the program. And we will cover that as well, although in all likelihood you probably have the field version. The binoculars are a different kind of projection, a graphic projection for target-oriented projections, and we will go over that in detail. This is the button that you use to add surveys, and you can, you click on that and it allows you to be able to put in surveys, a long list of surveys pretty rapidly if you want to. And then you have the plot button, which gives you a field plot, and the reports button, which gives you your report for your surveys. This tie-in button is a button which allows you to be able to put in tie-in information, and the PARMS button is the one which allows you to be able to set up the method of calculation and the units and a few other things that you need to set up for each survey file. And then the Save button saves the data when you click the button. There's an option where you can set an autosave for every 5 minutes, but generally in this program you click this button and make sure that it's saved. Now that we know our way around the main screen, it's time for us to start entering survey information. When you initially start a new file, one of the first things that you should do before you start entering your data is to do a couple of checks. One, you want to check your parameters. And as you can see, this button over here will bring us to the parameter screen. And it will keep the settings that you had set last. And most of the time that's always going to be minimum curvature. There are rare instances when you won't use minimum curvature, and usually that's per request of the customer for one reason or another. But you want to make sure generally that it's set on minimum curvature. And depending where you are, whether you're in what units you're using, you go ahead and you set your units as to feet or to meters right here. You can actually convert from one system into another system, and there's this rather awkward explanation on how to do it here, but it's probably about 1 in 1,000 people that will actually have to do a conversion. So you know, you can pretty much figure it out. It's documented in the written documentation if you want a more precise explanation. And then there's the output direction, and generally most people are using decimal these days, but there are still occasions when you want to see your directions output in quadrant, and you almost always put your information in decimal, but there's occasions too where you can input in quadrant and it will default to the input direction one way or the other. The vertical section reference here should always be set to other reference in 00. Don't use wellhead. It's the same as other reference in 00. And the only place where I've ever seen this east-west north-south reference in here set something other than the 00 was in Australia, where for some reason, I believe it was ESSO, wanted to have all of the vertical section distances on their wells referenced to a single wellhead. So that was their call, and that's why that's there. The second thing that you need to do is go ahead and decide which curve you're going to use. And curve 0 is by default the curve for entering new data as drilled information, but you can change it to whichever one you want by simply changing this number over here. If I wanted to put it into 10, I could change that to 10. The plan number is conversely stored here, and that is set in 1. My suggestion is that generally you keep your current as drilled here and your current proposal that you're trying to follow here in curve 1. And if you have to do a sidetrack, there are ways of moving these curves around and doing to other curves that are empty. But the first thing you need to do before you get started is put in some heading information. And it's just as a general rule, it's a good idea. You don't absolutely have to do it now, but it certainly is a good idea. So I've already taken the liberty of going ahead and filling out this information so that we don't spend a lot of time typing in information here. And you can see that it has the job number and the company and the lease well and the location, the declination, the grid that you're using, or true north, or I see a spelling error here. And the RKB. Now RKB needs to be explained in a little bit more detail here because it's a little bit different than what you may or may not be used to in using, because it encapsulates different things, but I'll go into more extended detail on that later. For right now though, this RKB that is stored here is only the RKB that you're going to have on your reports, and it can be representative of the total, as it is here, the total elevation above mean sea level, or it can be what it really by definition is normally meant to be, which is the elevation that the rotary Kelly bushing is above the ground, but not necessarily including the elevation. But it's quite common practice to have RKB be not only the elevation, not the elevation above the ground, but the total elevation above the datum, which is normally the mean sea level. So we're going to close that one out, and we're going to move on to the next step in our organization for what we're going to do. And we need to, as I said, select the curve that you want to work with, and then we're going to type in the name that we want to work with. And we're going to call this our as drilled well, and then we're going to come down here and we're going to select all the different types. You know, you can see various types of curve information that you can have in here, and I don't know that we're going to explain all of them here, but some of them probably should be explained in a little bit of more detail. But the proposal is if you have a proposal curve. Survey is if you have a survey as drilled curve. The dip line, hard line, lease line are different types of survey data that you can use. A dip line would simply be if you were going to have a line that you wanted to show on a plot, you could actually put in a survey line at a particular inclination and azimuth and direction, and you can make that line go across the plot. There's a tool in the edit function up here that allows you to do that. Then there's the hard line and lease line. And hard lines and lease lines are generally kind of necessary to display when you're doing well proposals and things like that. And what WinServe does, instead of having a specialized editor for putting in hard lines and lease lines, it uses a little trick that you can do with surveys. And that's explained in the documentation as well. But basically, in short, what you do is you create a survey at 90 degrees, and when you turn in a very, very short distance, and you establish the direction. For example, if I wanted to go from 0 degrees direction to 90 degrees direction, and I wanted to go 100 feet and then 100 feet in the 90 degree direction, I'd have 100 feet at an inclination of 0 and a direction of, say, due north for 100 feet. And then I would have my next survey at 100.001 at 90 degrees, and then I would show my next survey at a total MD of 200 feet at 90 degrees. And because the turn on the second survey was executed in an extremely short distance, it makes what appears to be a right angle and goes straight for it. So it's a little trick, but if you need to do that with a hard line or least line, it works just fine. And then a projection is just a projection curve that normally we use in our curve 21 or in our other projections. And the SAG-D input, the call search, and the XYZ are all specialized types of surveys. The XYZ being the most obvious out of them all, which would be a survey that you can not have the inclinations and the azimuths for, or the measured depths, but you have what's normally calculated by those, which are the east, west, north, south, and TBD values. And you can put those values in with that. And then the inclinations and azimuths and measured depths that are calculated on a tangential basis when you use that particular kind of calculation. Or curve, I should say. So we come here to the survey, and then we have the offset, the north offset and the east offset, which for our reference well will always be 0, 0. And then we have the vertical section direction and the RKB elevation. Well, I'm going to put in 75 here for our RKB elevation because each curve has to have its RKB defined, and that's because curves can be drilled, wells can be drilled at different times by different rigs, and so over the course of time you can have different RKB elevations on the same slot. The vertical section direction here, just to keep things nice and clear, we'll make it a 45. We have yet to create the well path that we're going to drill, but we'll do that in a later exercise. For now, we have established what we want to do here, and we are ready to start adding surveys. To add surveys, I can either click here on the spreadsheet and it will bring up the adding dialog, or I can go down here and just click on Add Survey and it brings up the Add dialog. So we're going to drill down, we're just going to put in some very quick surveys here, and I'm going to change the directional input method from quadrant to azimuth here because I don't like quadrant. We'll come down here to 200 feet and we'll start giving ourselves a little bit of play here and get some directions and whatnot. And 300 feet, 0.4, and say 12, and 400 feet, we'll say we've got 0.6 degrees, and we've got 34 degrees azimuth, and 500 feet, we'll say that we're back down to a 0.4, and we have 49 degrees. So we're drilling ahead here, and the important thing to note here, if you will look at this little note right here, it says that if you want to add in a lot of surveys at the same time, that you hit the enter key. And you just, the more you hit the enter key, and then when you get to the end over here in azimuth and you hit the enter key, it automatically wraps around to the next survey. If you hit the tab key, which is the most common key, as you will learn that you're supposed to hit to accept data in WinServe, then it is assuming that you're only putting in one survey at a time, and you'll have to get out of the screen and come back into it to add more surveys. So as you can see, it's a very straightforward and easy process to add surveys. Now I'm going to show you how you can
insert surveys, delete surveys, and do some special things with surveys, such as create a target out of a survey. If I want to insert a survey, let's say there's a survey here that I forgot to input here at 350 feet. I would select the survey on the extreme left so that the line is highlighted, as you can see there. And then I would press the insert button or insert key on the keyboard. And I come over and click on the next line. I put 350. And what it's done is it's made a copy, because it needs to have some survey data there. It's made a copy of the data on the line that I had selected. And now it's asking me to go ahead and put in whatever information that I may have. And I have gone ahead and inserted that survey at 350 feet, and it's been recalculated. Then I decide, well, okay, gee, I don't need the survey at 300 feet. I only have that survey at 350, and so then I select that key, or that row, and again select it just like I was going to insert. And instead of hitting the insert key, I hit the delete key. And because deletions are a little bit more scary than insertions, it asks me if I want to continue on. I say yes. If I want to delete a range of surveys, then I can go ahead and select multiple lines here. I can either hit the shift key, which is for each line, each one that I want to select a row, and hold the shift key down and move the mouse along and then select it. And then I can press the delete button. And it comes up and it tells me I'm about to delete 3 surveys from the range 200 to 400. And it's not okay. That's not what I really want to do, but I did want you to know how to do that. Okay, so I'm going to cancel that out. And I'm coming to the next stage here. And the next trick that you can do with this is creating a target point. Now, we're going to see this a little later, how this works, especially when we're doing our projections. But for right now, I'm just going to select a line, select this line right here at 400 feet, and I'm going to press T, and it brings up this target list, and I've got a bunch of targets here. We haven't entered any targets. That'll be our next exercise. But I'm going to enter a target here. I'm just going to click this and click at 1. And I'm going to come over here to the target screen, and this will be your first time seeing this target screen. But this screen right here is taking that point and turn that target into the target that with the coordinates, the TVD, the north-south and east-west coordinates of that particular survey point. When we use that tool to pick a point off of a proposal curve that we want to target with our projections, it's a very useful tool. So, at this point, we have basically learned the basics of what is necessary in order to enter surveys, and you can edit your surveys. Anything that is in the MD inclination or azimuth is editable. The black area up here, all that data can be entered. That's tie-in data. And the tie-in data that you have there is the same tie-in data that you're going to have in over here. And you can put it in either spot that you wish. Notice that we have a subsea depth displayed here, and that's the RKB elevation with the minus 75 feet being displayed. So we've got everything here ready to go, and it's time to move on to how to input targets. Now the next item of interest to us is to enter a target. Often when you go out to a job, you may already have the targets entered for you, but if you don't, you would need to go ahead to go into this targets button. This targets button, the screen is organized into two parts. The upper part is where you enter the boundaries of the object that you have, and the lower part is where you enter the coordinates of the object. In this case here, we have a circle that's entered on the first one. In an earlier part of the lesson, I created this from a survey point. And now what we're going to do is we're going to change this to a different kind of target. We're going to change this to a square, and we're going to change the target to a target that's at 8,000 feet TVD, and we're going to enter a coordinate of 1,300 feet by 1,300 feet, and we can see that we have a polar direction of 45 degrees, which is also closure direction, and we have a polar distance of 1,838.48 feet. What we need to do now is enter the size of the square, and we navigate to the top up here, and we put in the size of the square, and we'll say we have a 100-foot square, and we select that. Now the next thing we're going to do is enter another target, but we come down here and we select a target shape from this drop down. We're going to choose a circle this time, and we're going to put a target at 9,500 feet. So I type in 9,500 and then I press tab. And this time I'm not going to enter the coordinate of north, south, and east, west. I'm going to go ahead and enter in the polar direction, which we'll say is at 50 degrees, and it is at a distance of 3,000 feet. Now later, when we start doing our projections, we'll create a projection that goes from the first target through the second target. Right now, I just realized I forgot to put in the dimensions of the circle. And again, I have to come up here to this area of the screen up here and type in the dimensions of the target. I'm going to put in a 200-foot diameter. It should say diameter there. It does. And we can see the circle. Now, one very important thing to remember when you are in this particular part of the screen and you enter your numbers, always hit the tab key. And when you hit the tab key, you should see a shape of in this white box right here. When you do, that's an indication that you have successfully entered it into the array space of the program. Now we're going to go over a couple other details about what's going on this target screen here. One of the things that we can do is we can rotate targets. And I'm going to go back to this first target, a square target, which is obviously something where we can see a rotation. I'm just going to type in a number here, 45. Okay, so I've got a target rotated at 45 degrees. Or I can type in the 12 and it'll rotate it at 12 degrees. The thing that's necessary to understand here is that when you rotate targets in WinServe, the target is already pre-rotated to the direction of closure for that target. So if I have a rotation of 0 here, then when this target is drawn in the plot, we will see this target so that the lower side of that target is perpendicular to the direction of 45 degrees, because we have this particular target has a direction of 45 degrees. So if we wanted to rotate this target so that this target was going to be rotated so that it was facing north instead of at 45 degrees, the little trick that we need to incorporate here is that we need to subtract the closure direction from 360 degrees. So 360 degrees minus 45 is 315 degrees, so I'd enter 315 degrees. Now when we draw that target, as you will see later, it will be facing north. Okay. Now the other elements that you'll notice are in here are things like inclination and azimuth at target and things like that. And these are numbers that are generally updated by the software and the projection tools. The inclination at azimuth and inclination at target would be when we have a vectored target, and that's where the inclination and azimuth that we want to be at when we reach that target is stored. These numbers are not always utilized, but they are utilized by those tools that use them. This number right here, in the red column right here, we have an inclination from last target and azimuth from last target, are not numbers that we can enter. These are numbers that are, in fact, calculated and are based upon the geometry and the angle and the inclination between this square in this case and target number 2. Generally, if we're going to have vector targets where we want to align targets, we want to go in a straight line from the first target to the second target, and the numbers that we would enter for the inclination and azimuth would be the same here as they are here. So although we don't have to enter them, and as you will see in the projection tools that we use, it really is not necessary to do this, but I'm going to enter them here anyway just to indicate that we have the same inclination and azimuth at here and there, and when we get to the those tools, you'll see how that pops up. So for now, we have successfully entered our target. One more important point here is to remember that the target that we are currently on when we leave this screen is the default target that our target projection tools are going to be using. And so you want to make sure before you leave this screen that it is on the target that you want. And this is the target. This is where we'll come back to reselect the other targets. For now, we're going to leave this screen and we're going to begin discussing projections.